Okay, so thank you very much. So dear guests, dear audience, this lecture is oriented about some basic ideas and some aspects about how in present are data acquired in companies analyzed, and maybe we can look on some traditional or very effective methodology called as a business intelligence. So in this lecture, I will concentrate on several topics. After a short introduction, we make a survey about data analytics, and we look on business intelligence and also data business intelligence platforms that are connected to this topic, and some traditional solutions. So some examples of data, mostly data are the argument with the highest value, because with the data we can read the user behavior, we can read many things on the market. For example, it's a quite known example when a railway company in one country, concretely in Germany, according to the data analytics, was able to find out why their well-known Intercity Express trains were very often delayed. After this data analysis, they were able to shorten these delays and to provide more effective transport with this kind of trains. Or other kind of analyzing of data, like joining football players into top team after the deep analysis of many factors of how is the coincidence of players, or the coherence of the speed, or kind of the play of the players, and so on. Other kind of analyzing the data, quite popular nowadays, mostly on e-shops, where these companies are focusing on customers based on their typical behavior, like previous shopping, previous transactions, or preferences, maybe wish list, and so on, and other external factors. So what about the data? We can say that amount of data the amount of data is now available to organizations on products, customers, competitors, business operations, which is increasing, say, exponentially. This data comes from many sources, such as sensors, Internet of Things, websites. Organizations are collecting and storing the large amounts of data, and most of them collect this data with hopes of using it to innovate and gain an advantage over their competitors. But in actually, only a small percent of companies are using the data that have collected. According to a recent survey provided by IBM company named "In Idea, Smarter Computing to Big Data Analytics and Path from Insights to Value," most organizations only use approximately no more than 40% of the data they have collected. This some source also states that there is a lack of understanding among business managers about how to use analytics to improve the business. For most firms, the data collected is typically left stored in repositories and mostly not used. Therefore, for organizations, the want to use data to innovate or gain an advantage over their competitors, just collecting it in large quantities is not enough. In the new analytics economy, the basics of how to thrive are entirely different. What does thriving in this new reality look like? Data is the foundation of the new economy. It is the raw material which contains the value. And as we all know, there is more data and more diversity of data than ever. So there is more value available than ever. However, data stuck in data warehouses and data lakes is of no value. If we are honest with ourselves, there are more data graveyards and data swamps than highly valuable data warehouses and data lakes. There is no value in raw data unless analytics transforms it into insights. This means analytics must be able to check all the data, find the relevant combinations, and surface the right insight in a way that's easy to use. Analytics must also be able to adapt and derive or evolve as the data grows and changes, and as user behavior and use case evolve. Analytics are similar to data in that the analytics alone are of little value unless people actually use and benefit from them. Insight that is created by analytics must then drive action that transforms businesses. If it does not, then it is generating little value beyond perhaps a feeling of comfort or seeing the number. If the only output of analysis is, say, business as usual, then the business would be just as successful without analytics. It is absolutely essential that insights, which by definition is new information, drive change and ideally transformational change. Some may be curious view on data. We can look on acquiring data from many points of view. For example, this is not business, but typical mathematical problem. This is so-called Collat's conjecture, which is a function about that many scientists thought that please never do your research with this function, otherwise you couldn't simply stop. And many researchers thought that after starting to do a research with this simple function, they practically devote their whole professional career, more than 30 years, about research of this function. This function is quite easy, but it produces very interesting data from which we can read many interesting properties. However, it is not a business function, but also in this area, we are able somehow to analyze the data and to give some answers based on the results that we simply see or that we simply acquire. Okay, let's look on some preliminaries in data analytics. What can be often seen in companies? Roughly speaking, software engineers always say that the highest top level of using software engineering is storing and analyzing all data in simple Microsoft Excel tables. Why is it so? Because it's very easy. It's ready to use, and practically it provides everything what for standard and say not very high level data analytics we need. But data lineage is generally defined as a kind of data life cycle that includes the data's origins and where it moves over time. This term can also describe what happens to data as it goes through diverse processes. Data lineage can help with efforts to analyze how information is used and to track key bits of information that serve a particular purpose. One common application of data lineage methodologies is in the field of business intelligence, which involves gathering data and building conclusions from the data. Data lineage helps to show, for example, how sales information has been collected and what role it could play in new or improved processes that put the data through additional flowcharts within a business or, say, organization. All of this is part of a more effective use of the information that business or other parties have obtained. By year 2025, it's estimated that humanity will have produced a total of 175 zettabytes of data. For context, it is practically 175 with 9 zeros. It's quite a huge number. 175 with 9 zeros of terabytes, of course. A look into structured and unstructured data. Their key difference is from which best meets most business need. As we can see, we have more classes of data or more stages how data are organized or collected, starting with standard data sources where data can be considered structured or unstructured, then quite a notion of big data, generally structured data, then data warehouse, and then reporting using dashboards and some algorithms, mostly the business intelligence. So, roughly speaking, all data is not created equal. Some data is structured, but most of them is simply unstructured. Structured and unstructured data is sourced, collected, and scaled in different ways, and each one resides in different type of, say, database or other repository. So generally, what can be considered as a structured data? I don't want to bother you with the technical definitions, so I try to very briefly describe. Structured data, typically categorized as quantitative data, is highly organized and easily decipherable by, for example, machine learning algorithms. For example, developed in 1974, structured query language as SQL is the kind of programming language used to manage structured data. By using a relational database, business users can quickly input, search, and manipulate structured data. Standard examples of structured data include like dates, names, addresses, for example, credit card numbers, etc. Their benefits are tied to ease of use and access, while liabilities revolve around data flexibility. Of course, pros and cons, very briefly: easily used by machine learning algorithms or accessible by more tools since they are structured, and then some structured schema for manipulating this data can be prepared. Some cons: limited usage or limited storage options. About some data tools, standard database systems like SQLite, MySQL, Postgre, and so on. And typical use of structured data: there are customer relationship management, CRM software, which runs structured data through analytical tools to create data sets and to reveal customer behavior patterns and trends. For example, online booking like hotel and tickets, accounting, and so on. Now, unstructured data. This is typically categorized as qualitative data. They cannot be processed and analyzed via conventional data tools and methods. Since unstructured data does not have a predefined data model, the best way how to manage this data is non-relational database or non-relational model. Non-relational, they are typical like graph databases, then textual databases, and so on. Another way to manage unstructured data is to use data lakes to preserve it in a raw form. Of course, importance of unstructured data is rapidly increasing. For example, recent projections indicate that unstructured data is over 80% of all enterprise data, while 95% of business priorities unstructured data management. Typical examples of unstructured data include text, mobile activity, social media posts, Internet of Things sensors data, etc. Their benefits involve advantages in format, speed, and storage, while liabilities revolve around expertise and available resources. To the pros of unstructured data, their native format, and then also fast accumulation rates, and data lake storage, which is a quite huge repository, kind of huge repository for storing unstructured data, and also requires expertise. What about typical use cases? Data mining or chatbots, where chatbots perform text analysis to route customer questions to the appropriate answer sources. Then what about data warehouses? Typical solution for business solutions of storing the structured data. Data warehouse is data management system that stores large amount of data for later use in processing and analysis. We can think of it as a large warehouse where, for example, trucks like source data unload their data. That data is then sorted into rows of well-organized shelves that make it easy to find exactly when we are looking for later. What about the big data? Again, quite common notion. It is a combination of structured, semi-structured, and unstructured data collected by organizations that can be mined for information and used in machine learning projects, predictive modeling, and other advanced analytics operations. Sorry. Systems that process and store big data have become a common component of data management architectures in organizations, combined with tools that support big data analytics uses. Big data can be characterized by 3 V's, like the large volume, wide variety, and the velocity. And what about the dashboards? Dashboards are typical business intelligence reporting tools that aggregate and display critical metrics and key performance indicators in a single screen, enabling users to monitor and examine business performance at a glance. Dashboards extract and communicate high-level insights such as anomalies, issues, and trends for end users and all skill levels before they choose to analyze data in more detail using advanced mechanisms like contextual objects and contextual analysis. As a high-level reporting mechanism, dashboards ultimately provide fast, say big picture answers to critical business questions and assist to benefit decisions making in several ways, like communicating how business is performing according to defined targets, then improving informational awareness for everyone, organizing operational data into a well-managed format, or visualizing complex relationships in easy to use and easy to understand way. What about business intelligence? Business intelligence comprises the strategies and technologies that are used by enterprise for the data analysis of business information. Common functions of business intelligence technologies include reporting, online analytical processing, analytics, data mining, then process mining, complex event processing, business performance management, then benchmarking, text mining, and for example also predictive analytics and prescriptive analytics. Basic operating decisions include product positioning or pricing. Strategic business decisions involve priorities, goals, and directions at the broadest level. In all cases, business intelligence is most effective when it combines data that are derived from the market in which a company operates, that are called external data, together with data from company sources internal to the business, such as financial and operational data, which are called internal data. When combined, external and internal data can provide a complete picture, which in effect creates an, say, intelligence that cannot be derived from any singular set of data. We say that business intelligence is an umbrella term that includes the applications, infrastructure, and also tools and best practices that enable access to the analysis of information to improve and optimize decisions and performance. Some principles of business intelligence. Business intelligence is also called descriptive analytics in that it describes a past of current state. To compare that explanation of business intelligence with the definition for business analytics, a technology-aided process by which software analyzes data to predict what will happen in predictive analysis or what could happen by taking a certain approach in prescriptive analysis. Then business analytics is also sometimes called as advanced analytics. Data can be monitored where results are considered as reports or dashboards that are called standard raw data. Then exploring is the next phase, which means that based on known facts to sort out data for some purpose, which is the first stage in reading of data. Then next stage to investigate and to connect facts for predicting the new facts, for example, based on machine learning or deep learning, which is a higher level data based on previous facts. And then performing, where the system can predict new facts based on learned associations on data, which means data thinking and predictions based on, for example, also algorithms of artificial intelligence. Unstructured data must be somehow organized and stored for future use. Using artificial intelligence can many informations be predicted. What about the controlling based on machine learning? Data can be at home or say outdoors. Then both forms can be input for analysis or on the connectivity. To monitor and to explore are stages which can be realized manually by reporters. Added value could be then why, answer to why, mistakes and problems, and another answer to how, in connection to how to solve the problems. This process cannot be done manually, so let's take visualized data and let's find some problems. This is the outcome of business intelligence platform. We can find the answer for why and to how to solve the both questions. Technical solutions that are available on the market. There are many, really many solutions provided by some companies. I listed only some of them, some of the most typical. There are also some other typical. According to statistics of the Gartner company from the 2022, the role on the, or the position on the market can be depicted by this diagram. For example, Click as a platform is positioned as a, or was some years positioned as a leader, driven by a robust product on above average customer experience and a strong global partner network. Then isolating for ClickSense, it has matured into a commercial success, now making up more than half of the license revenue, making it arguably the fastest growing product in the business intelligence industry. Ability to perform, Gartner scored Click low categories such as licensing and support, and for perceived uncertainty having been taken private, and so on. So there are many criteria how to evaluate these platforms according on how to on what they focus on, how to perform their solutions, and where are they usable. And the result of evaluation for beginning of this year we can see on this picture. So some more words about the ClickSense, for example, is a next generation platform for modern self-service oriented analytics. It supports similarly like other platforms, full range of analytics use cases across an organization, including self-service visualization and exploration, guided analytics applications and dashboards, which is the most visible added value. Then custom embedded analytics, mobile analytics and reporting, all within a governed multi-cloud architecture that offers trust, scale, and ongoing choice for the organization. These are strands of many platforms that are on the market now. So cannot say that this is focused on this one platform. So some approaches. There are three important approaches to business intelligence when looking on business intelligence as a service. In traditional method, when stepping back from data source, there are some processes how to evaluate data and how to analyze them to provide some answers, analytics. But this was organized in stages and phases, and the same process is repeated by all users for each changes in these reports. But other analytical platforms that is available on more of these platforms available on the market, we can look on business intelligence as a service, considering the business intelligence as service versus its implementation, then as a service based on internal data, and also as a service based on external data. Another approach is considered as a hybrid approach of all these approaches. So traditional query-based methods or business intelligence tools, predefined viewing angles and restricted linear explorations. Associated difference in some platforms, products frees users and organizations from the limitations of query-based tools. What is then? Why is this important? Simply put, Some relational databases and SQL queries were not designed for modern analytics. While it's true, then most modern visualizations tools rely on SQL to pull data from their sources, including also business intelligence platforms. Other tools depend on SQL and query-based approach as their fundamental architecture for modeling data and supporting interactive analytics. This is the major flaw in their approach, resulting in restricted linear exploration and analysis on partial subsets of data. In other words, someone has to bring data sources together using SQL joins and make assumptions about what types of things users will want to know in order to pull the data accordingly. All other data is left behind. If user wants to pivot in their analysis based on something they saw, they have to rebuild complex SQL queries, which often means going back to a more experienced data expert. We call this the ask, wait, and answer cycle. Every new type of question has a waiting period, of course. These modern platforms for business intelligence set out to address this problem with its patented, many times also innovative engine designed specifically for interactive freeform exploration and analysis. All data is brought together and fully indexed to find all the possible associations in the data across all given data sources. With business intelligence platforms, reporting leaves no data behind, even when combining large numbers of data sources. Instead of pre-aggregating data or relying on database calculations, business intelligence platforms offer powerful on-the-fly calculation and aggregation that instantly update all analytics and highlights all associations based on user interactions. This simply means that people are free to explore, search, and pivot based on what they are seeing without limitation or ever waiting. They do not have to go back to experts and wait for new queries or aggregations. It's all there, waiting to be explored fully. This is why business intelligence platform offer to user experience previously unforeseen insights. The associative model powered on business intelligence platforms makes data discovery and analysis a very easy task in the business intelligence tools. Basically, through these associations between data tables, a logical connection is made by linking relevant data fields and data values with one another. When all the relevant data residing in the entire data set link with one another, then it forms a logical structure of data and gives some meaning. So comparing traditional and also modern approaches in business intelligence, in the beginning of these approaches, there was an approach how to somehow construct the associations on data with some standard data structures, for example, tree structures, hash maps, and other very powerful data structures, but many of them have also some drawbacks. In a modern approach, when we use dynamic associations, these associations are constructed over all data fields in the company repository with all company data. And for exploring the associations of data, also modern approaches like artificial intelligence or machine learning are used. So, when the platform is open, it is also suitable to prepare a connector among the platforms. Mostly some REST API can be used, like standardized format of data flow. Stepping back to some concrete platform, this Click Modern Analytics portfolio starts with the platform and the unique associative engine, which is the key to how unique values are referred to the customers. Associative difference fundamentally addresses the weakness of query-based approaches, allowing to bring together all the data and explore it without the limitations of query-based tools. The unique differentiator is at the heart of everything, say from the products and solutions to the innovations, mostly using standard and new approaches. To say this is not the only platform, I just want to point out some typical strengths of one platform. With the other platforms, it is very similar. Most of these platforms orient to combination of external and internal data stored in many kind of repositories that can be somehow connected and associated across the whole repositories. So this is typical approach in companies, enterprises, when analyzing really a huge amount of data, trying to find some associations, trying to find the answers to some concrete questions about relationships and dependency on data. So typical modern approach. We say that on the top of this foundation of platform and data, standard analytics solutions are offered. So starting from the input, which is the data acquired from market, from the company, internal and external data combined together and analyzed and stored with some platforms. Then solution is to start over with business analytic platform, which is able to make a survey of this data, then analytics to provide the results, connections, associations, and answers, and then to use this acquired data in typical use cases in companies and providing the services of the company. So let's go for a short summary. So for the technical aspect, I wanted to orientate this this lecture to give some general information about how to work with data, how to make a survey about typical solutions on the market, typical way of storing, acquiring, and analyzing the data. Then about societal aspects, we are of the opinion that this approach in practice is, however, it is quite modern. It's quite okay if it is included into curricula and when students have at least some chance and the possibility to see the real solutions and to learn about, for example, in our university, we have very nice connection with companies, and we provide also for students live IT projects where they are able to be integrated for one semester into companies and to participate on software solutions and to have a real experience with software developed by company and with the data stored by company and managed by company, and also to provide their own solution based on requirement of the company. And some business aspect, everything taking together, all this experience should be able to provide also for students in their future, also some experience that they are able to use not only in technical but also in business aspects. So thank you for the attention. It was the survey about these algorithms on market and companies and the connection to the reality. So once more, thank you for the attention.